how do we figure out the number of combinations of different things? Well, let me show you a quick example. Let's say we're going to a shop, and you can get a main course of chicken or beef, let's say it's a burger or something, and a choice of 3 drinks. How many combinations are there in total? Well, you might expect that there's, chicken plus Coke, then there's chicken plus water, then there's chicken plus lemonade, then there's beef plus Coke, then there's beef plus water, then there's beef plus lemonade. So in total we have 6 combinations, but there's actually a much faster way to work it out, because what if we had 5 different mains and 10 different drinks? Do we really have to add them all up? The answer to that is no, and this is really useful in many cases. Instead, here's a method that I use to work it out. Instead, I draw 2 little boxes. The boxes represent our choices. So for example, here it's going to be main and drink. And all you do in the boxes, you write the number of options you have. So for example, with the main, I have 2 options, so I'm going to write 2 in there. And with the drink, I'm going to write that there's 3 options. And then all you do is you multiply the numbers together to get 6 possibilities. And that's a really quick way to do it. So I'm going to show you a few different examples now and where it applies. This applies to a lot of different types of questions and scenarios. So the first one is, there are 12 boys and 15 girls in a class. 1 boy and 1 girl will be selected to represent the class on the school council. Work out the total number of ways of choosing a boy and a girl. Well, again, let's say that's for boys and this is for girls. There are 12 different boys, so we're going to put 12 here, and there are 15 different girls. And then all we have to do is multiply those 2 numbers together. And that's it, which would be 180. Again, let me show you another example. Here there are 3 different choices to make. There's a starter, main course and dessert. So again, all we're going to do is we're going to put a big box for each of these. We have starters, main courses and desserts. There are 4 starters, so stick a 4 on the front. There are 7 main courses, and then there are 4 desserts. And then all we have to do is multiply all 3 numbers together. So let's see, 4 times 7 is 28. And 28 times 4, so we double it, 56, double it again, 112. See how quick and easy this is? This one's a fairly interesting thing. There are 52 cards in a deck. Peter's going to give 1 card to Casper and 1 to Kelly. How many different ways are there of doing this? Now this is a bit interesting because we have to actually think a little bit. So there are 2 combinations, right? 2 choices, which is the first and the second card. Now, how many cards can we choose from in the first case? Well, there are 52 cards. So I have 52 cards to choose from, right? Now, if Peter's given one of these cards to Casper, how many cards are left for the second person, for Kelly? Well, that means there's going to be 1 less card to give, so that'd be 51, and then you just times those 2 together. That's it. So it's still the exact same thing. Now, here's an interesting case, because sometimes it's not as simple as what I've made it out to be. So it says there are 30 students in a class. 2 students are going to be selected to receive a prize. How many different pairs of students can be picked? Now, here's the total number of pairs of students that can be picked. Again, there are 30 options for the first choice, and there are 29 options for the second choice, right? So then all we have to do is do 30 times 29. So 30 times 30 is 900, so minus 30 would be 870. Now, why did I highlight the different pairs? Well, if you notice, let's go through an example really quick. Let's just pick, let's say, 5 students, right? So let's say Tom, Jack, Emma, Priya, and, I don't know, John. Now, if I write out these combinations, here's the combinations that we have. So we have Tom and Jack, Tom and Emma, Tom and Priya, Tom and John. Then we have Jack and Tom. You have Jack and Emma. Then you have Jack and Priya, Jack and John. I don't know if you've spotted what the problem is here yet. So let's do one more. So with Emma, we have Emma and Tom, Emma and Jack, Emma and Priya, Emma and John. Now if you notice, it says different pairs of students, but look at these combinations. Tom and Jack and Tom are the same combination. Tom and Emma and Tom are the same combination. Tom and Priya, and actually we didn't do Priya, so that one, it will be replaced again, but, you know. Tom and John, again we haven't done John's yet, but we have Jack and Emma, same. Jack and Priya, we didn't do Priya, so she hasn't got one yet, and so on. So if you notice, half of these combinations are repeated, right? So I don't need all of those combinations. And if you were to write out every single combination, you'd see that half of them are duplicates. So when it says something like different pairs or something along those lines, implying that you're not counting every single combination, but you're counting the different possibilities, then all you have to do at the end is half your number. So hopefully that makes a bit of sense. That'd be what, 485? So I'll give you another example. There are 8 teams in a in a competition. Each team plays every other team once. So we're not double counting here, right? Because the implication is different pairs of teams that are playing each other. Work out the total number of games played. So 8 teams in a combination. Again, if you use the same logic, if we had team A through E or whatever, well, E isn't actually the 8th letter, but whatever, you'd see that they get double counted. So again, we're going to do 8 times 7, because there are 8 possibilities for the first team, 7 possibilities for the second, and then all you're going to do is you're going to half it afterwards. So again, that would be 56, and then divided by 2 means there's 28 total number of games played. Now I'm going to show you some other situations which will hopefully make things a little easier for you. Here for the next one, there are 10 people in a room. Each person shakes each other person's hand once, again implying that it has to be different combinations. So again, for the first person and the second person, right, because 2 people shake hands, right? Well, there are 10 options for the first person, 9 options for the second. So we're going to multiply those 2 numbers together to get 90, and then we're going to divide by 2, because again, we want unique solutions here, right? So person A shaking person's B hand, and B shaking A's is the same thing, so we're not counting it, so we're halving the number. Again, this gets really important when you get into statistics as you get older as well. And lastly, let's do one last question, because this is a really common scenario they give you, which is a combination log, working out how many different possibilities there can be. So each dial can be set to one of the numbers 1, 2, 3, 4, or 5. Work out the number of 3-digit numbers. So again, now if you notice, it does say different 3-digit numbers. It doesn't mention that each digit has to be different, it's just the overall number. So how many options are there for the first number? Well, it can be 1, 2, 3, 4, or 5, so it's 5 options. Now for the next one, there's also 5 options. And for the one after that, there's also 5 options. So all we're doing here is we're doing 5 times 5 times 5, which is 125. Now part B of the question could be something like, how many combinations could there be if each digit has to be different? Well, then all you'd have to do is there are still 5 possibilities for the first number, but there's only 4 possibilities for the second number, and there's only 3 possibilities for the last number. So 4 times 3 is 12, 12 times 5 is 60. So it actually halves the number of combinations. So again, hopefully that helps out with a product rule for counting. Always think about if you're looking for different combinations, in the sense that, you know, each combination has to be completely unique. So for example, something like this, or like this, or if you're just looking for the total number of combinations when you're doing this.